BackRoomLabs here, guys. Today we're going to be demonstrating and showing you how to construct the crystal battery. Currently we got a little cell here powering a LED solar light. This is what we're talking about here. This is the crystal power cell. A guy named John Hutchinson first started messing with these things, and John Medini and one of his buddies kind of perfected it. Basically, we got a little solar LED light. I got the solar panel taped off here. Here's the little LEDs. These guys are actually pretty bright. I've had this one running for going on about 12.5 hours now, and the battery doesn't show any signs of stopping right now. I had it running yesterday for going on 8 hours. I disconnected it overnight. The battery went back up in voltage to its resting voltage of about 1.512 volts. When it runs this LEDs, it's the voltage drops down to about 0.85, and then it plateaus in that area and just seems to stay there. So I'm pretty impressed with that. We're going to go ahead and show you guys what it takes to put one of these together, and surprisingly it's not very difficult. First of all, we're going to have to go shopping. Pretty sure you guys can see these. First we have alum. This is a pickling agent used in making pickles. No salt, which is salt substitute, your Epsom salt, and your borax. These are all crystals. That plays a big role in this whole little power cell we're going to make. Okay. Next we'll have our copper, our magnesium core. This is standard plumbing copper I got down at the local hardware store. It's an 1/8". I sanded the inside, make it nice and shiny, and this is a piece of number 10 copper wire. I just stripped it, soldered it on. This will become a terminal. This is the magnesium. It's 99% pure. I've seen guys use the sacrificial stuff that comes in the water heaters. This is my first go at this, so I went ahead and got the good stuff. This is, I believe, 5/8 in thickness. Got these offline. I got 5 of them for $15, so that's not too bad. The rest of the stuff's fairly cheap. Okay, we're going to go ahead and mix some stuff up here. This is all equal parts. Let me reposition here. Start with the Epsom salt. Doesn't take very much. The first batch I mixed up, it actually got way too wet from just sitting out. I didn't seal it up good enough. Okay, there's one there. The alum is the most expensive. Each one of these little suckers was about $3. I've done some more research. I see you can get about a pound of this online from some spice stores. So if you plan on making a lot of these, that'd probably be a good place to go look. And last, the borax. This one's kind of a pain to pour out, so I'm going to just go ahead and dump some here into the bowl and then fill my little measurer up from there. This should be more than enough mix to probably do, I'm hoping all of these, maybe not. I might be a little short. That's alright though, you can always just mix a little more. Okay. And there we go. The old blender here. Okay. Now that these are mixed together real nice, go ahead and dump this guy out into the bowl here. There's actually quite a bit there. Okay. Alright. See these guys here, I'll give you a close-up of this. This actually took me a while to figure out. A guy named Laser Saber, he did this and his were a little smaller. I got a little bit bigger copper to allow more crystal to be in between the copper and the magnesium. I took 3 pieces of Schedule 40 PVC. One was 1 inch, one was 3/4, and one was 1/2 inch. I actually had to, I didn't have a heat gun, so I boiled the pieces to put them together, and then I sanded the outer layer down just a little bit. I've beveled the edges, and then I also beveled the inside here. It just, I couldn't get the sizes just right, so I had to modify it just a little bit, but this took me a while to figure out how to put this together. But this will be the end caps here, the seals, that'll keep the crystals from pushing out when they go to expanding through the process of ionization when they produce the current and voltage. Okay. Alright, so we got one of these guys here. Let's flip this over. Alright. It's a pretty snug fit, which is what you want. Tap that on in there. Okay. Might be a little off center. You can still move the magnesium rod around to get it just right. Just eye that up there. Okay. Make sure we're in view here. Okay. Now we're going to take the crystal, fill this up. completely dry. I just recently watched some videos where Mr. Bendini and his partner, the Epsom salts, have set out for a while, and they suck up a lot of water. And when he put his together under immense pressure, all the water started to push out and do some weird stuff. So I'm doing these dry to see what the difference may be, but if any. I just got a piece of 3/4 PVC here, just to smush this down in here to kind of get it going. You want this to be under a lot of pressure though, that seems to be the key. The more pressure you can get, the better. Go, Tyson, get. That stuff will compress quite a bit, you'll be surprised. I'd like to get a press to actually do this. I think it would give me a little bit more current when the battery's done. But this seems to work alright for the first battery. Not much to this, guys. Not much to this at all. There's a gentleman on YouTube, you can search under crystal batteries, and Laser Saber, I believe, is his nickname on there. And he has some of these power cells running little pulse motors and LEDs going on close to 900 days now, with very to little or no maintenance at all. He's got them just sitting on a shelf with a live video feed just to show the duration of these cells and what they're capable of. Very, very interesting stuff. I think we're about here. This is Laser Saber's technique also. I think I got a little bit much in there. Let's take that. Okay. She seems to be pretty packed tight. Okay. Now, we'll take one of our little top plugs here that I showed, and we will attempt to plug the top of this battery. Let's go ahead with this one. any luck, we should be able to pull some sort of a voltage off of this little contraption. Alright. Huh. Amazing. Look at this, folks. You seen it. You watched it. We put it together. Isn't that neat? That is outstanding. Alright. No tricks here. Disconnect. Light goes off. Pull this right out. Brand new battery, we just made it. Disconnect the meter. Okay. What happened? For some reason, this one does not seem to be working. Although we have a voltage. Very interesting. It's very odd. But this one works, and I've done the same thing. Let me pause this here. I'm going to grab a smaller LED and let me see what happens with that. Alright, we're back. What I figured out was I didn't have this light the first time I made this. I went to work and my girlfriend had picked it up when she was at the dollar store. She seen it and thought it would be something cool to see if it would work off the battery. Well, the first night I had voltage. I don't have a DC amp meter to check the current on it, so I didn't know. But what I did have was this little teeny LED. It's supposed to turn on at like a volt at 0.15 milliamp. So what I did was the same way I did this project the first time. I went ahead and went back and grabbed the light to see if it would light like it did before. Turn this off. Come over here and see if I can't get the camera on it. There it is. You see that it is lit up. Okay. Then it dawned on me that this salt solution here and all these crystals is called a hydrate. So what had happened was, over the course of about 24 hours before I had got off work and she had brought this little LED light home, the Epsom salt had time to wick some moisture out of the air, which actually helps create the connection between the cathode and the anode, the copper and the magnesium. And the crystalline structure inside of this is the conveyance for the ionization that happens between those two metals. And that's what allows the current and such high voltage. You'll see here, this battery has not hydrated yet. So it does have the voltage, it doesn't have any current to be able to work a load. We'll go ahead and pop that off there. But you see here, this battery is going on 2.5 days old. It is well hydrated, and I believe it will get a little bit better with time. This one has no problem firing up the LEDs. The way I see this battery here should probably support about 1.5 milliamps at about a volt. So at that rate, you could scale this up in series to 12 volts, parallel those with another 10 or so of those battery banks, and you should be able to have a pretty decent 12 volt supply at somewhere in the 8 to 9, 10 amp range. That at this time appears to be a pretty viable source of power for a couple years at least. Long duration run tests of these things are underway with this style type of cell, and so far they've been going for 2 or 3 years with little to no maintenance. And you know, once again, all these salts and crystals you can get at your local grocery store, and that's pretty much it. I'm going to go ahead and put the rest of these guys together, and once I get them all together, I'll let them hydrate for a day or two, and I'll be back with another video, and we'll see what kind of loads we can run off of these little suckers. Alright guys, Backroom Labs, thank you much. This is just a quick little diagram here, pretty much what you got going on. Kind of goes over everything. And again, you do got to let this sit for a while so the crystals will hydrate, which means it'll wick moisture out of the air, which will allow continuity between the two metals and the whole reaction to take place. Here was my first run with the LED. The dollar store solar lamp had a battery in it that had this rating on it. It was a little rechargeable NiCad. 100 milliamp hours at 1.2 volt. Okay. Starting voltage on that battery was, you see it there, about 1.5 volts. Here's my time scale and my voltage measurements. It held pretty steady for about 40 minutes or so, and then here it just fell off. It just jumped off a cliff, and it slowly leveled out. Once it did level out, it kind of hovered there, and I disconnected it there at 11 o'clock, went to bed. Got home from work the next day a little early. Got home around 12 o'clock. And I went ahead and started the test again. 1240, voltage had went back up from being disconnected last night to right here. Just left the battery sitting on the table and didn't touch it or nothing. And then this is right after I connected the light. The initial voltage drop. And you see here, another day with the battery sitting, I'm sure it's accumulated a little more moisture in there. It's probably becoming properly hydrated now. And you can see here it ran all the way till 9:30, and that's where it was. If we do a quick little check on that cell here, okay, it's 9:30. It is now 11:30, And you seen I was just playing with that battery here a moment ago, showing I made the other video. And let's go ahead and see what the voltage went back up to. This is the really interesting thing about these little cells. Okay, just go ahead and clip up our little clips here. We'll put our meter down here to VDC. Look at that. It's already back up to 1.5 volts. That's where it plateaued at and was just hanging out down there. You can see from 730 to 930, that's the drop there in voltage. Now, I'm thinking I'm going to go ahead and pull the little resistor out of this guy here, rewire this, and you see that little resistor there? It's got a little circuit here because it used the solar to recharge the little battery, and then you know, of course when the sun goes down the little light would come on. But that gives you a good idea of what's going on with these things so far.